The first part of this is a quadrilateral. We're looking at a four-sided figure. It's a four-sided polygon. There's really not much speciality to it. One thing that we figured out yesterday was one thing. One thing that we learned yesterday was something about the angles. What was something about the angles that we learned? They all add up to 360. For the basic definition of a quadrilateral, by definition, if we're just talking about the angles, none are congruent. But all add up to 360. Adds to 360 degrees. So we're just talking about the angles to begin with. So if none are congruent, the way we can mark that is with specific different angles. So this first angle that we're seeing here will be our 1. This will be 2. We'd usually stop with 3, but because we have 4 sides, 1, 2, 3, 4, that represent each different angle, okay? That's the properties that we usually want to be able to see with these, okay? And that's the basic form of this. So if no angles are congruent, but they all still add up to 360, four-sided figure is definitely a quadrilateral. The next part that we're going to also talk about is sides. Okay. One thing that we're getting from these properties is we get none are congruent. No sides are parallel. And the way that we represent that is just by showing different sides are not congruent. So one side here, 2 sides here. Get my regular colors. The green. 1, 2, 3. And our last one being 1, 2, 3, 4. The other one that I'm hoping you guys have room for, and you guys want to put this right down below it, is we also want to be able to talk about the diagonals. In a triangle, do you have diagonals in a triangle? Think about it. Right? You really don't. You don't have them. You're just constituting on the sides. But as soon as we add another side to it, we can now talk about diagonals to it. So in this case that we're getting here, our diagonals for this, if we're talking about the space between them or the lines between them, we're looking at these parts here. Okay. None are congruent. And another thing we could say does not bisect. What does bisect mean? How about this? What does bi mean? 2. So bisecting means splitting into 2. Okay. It does not split up the parts into 2. Okay. Could it? Yes, sometimes, but not all the cases. In this case, in a regular quadrilateral, we get none that split it into 2. Okay. And that's all you really want to have for that one. Okay. Yes. All quadrilaterals have diagonals. Yes. Mm-hmm. Yeah. All quadrilaterals have diagonals. Okay. So here we go for the next one. Here's the next one right next to it. Here's a parallelogram. So go ahead and copy that part down. By definition, to make a parallelogram different than a quadrilateral is opposite sides are parallel. Any quadrilateral that has opposite sides parallel is considered a parallelogram. Okay, a square is a parallelogram. Opposite sides are congruent. Okay, rectangle, opposite sides are congruent. Therefore, it's a parallelogram. Okay, so this encompasses a lot more than just one type of triangle. Okay, and we're going to come up with different properties for this one as well. We are going to look back at this one in a little bit, probably next week when we talk about the properties. You can get a lot of properties that stem from the idea of a parallelogram. Opposite sides are congruent. Diagonals bisect each other. Adjacent angles are complementary or supplementary. Yes.
What was the name of the other one?
For the first one we did?
Yeah, it was a quadrilateral.
Quadrilateral. Okay. So again, looking at the types of properties that we want to be able to look at is the first one we talked about was what? Angles. Angles. So angles in this one. So we're going to talk about the angles in these. What was the main thing that we got from this yesterday? Again, opposite angles are congruent. Opposite angles are congruent, which kind of matches up with these ones. And we're going to go ahead and put another line to distinguish between these two to show that these are different. So we'll put 2 on these ones, 1 on those other ones. So we know that the opposite angles are congruent to these. What do the angles add up to be? 360. Adds to 360 again. Okay, and the last property that we did not tell you yesterday, but adjacent angles, so ADJ, are supplementary. And I'm going to go and label this 1, 2, 3, and 4 to say that 1, or how about this, angle 1 plus angle 2 will equal 180. Angles 2 plus 4 will equal 180. Angles 3 and 4 will equal 180. And 1 and 3. So any angle that they're near are supplementary. If they are across from each other, they are congruent, so they're equal to each other. The next thing that we want to be able to see here, and it kind of stays in the definition, for sides, when we talk about sides, one thing that we know by the definition is opposites are parallel. This what makes the definition of a parallelogram stand out. Okay, opposite sides are parallel. If we continue on this idea, meaning I'm going to go ahead and show you guys what parallel looks like for our figure. The way that we kind of show that to show parallel is we show arrows in the same direction for these. It doesn't necessarily show congruence, but it shows parallels. So the more arrows you add, the more tells you what sides they are. So we have one pair which are blue, tells we have 2 arrows going in the same direction, shows us parallel. 2 in red to kind of show the second sides are also parallel. Okay. Another thing that we know about the sides is opposites are congruent. opposites are congruent. And again, the way that we note that one is we just by lines to show congruence. 1, 2. So these are why they're kind of helpful when you guys have different colors. What's the last thing we need to talk about that we didn't do before? Diagonals. Diagonals in this case are a little bit nicer. So I'm going to kind of do this on top. This one has a lot of the definitions, so we're going to kind of show everything for this one. For the diagonals for this case, show in a different color. If we're going to go from 2 to 3, 1 to 4, okay, the way that we're going to kind of represent this is not congruent. And this is to make a basic parallelogram, okay? We're not talking about a square. We're not talking about if nothing else holds, what holds? In this case, not diagonals, yes. If you want to title out the diagonals were not congruent, you would just find the measurement, find the length of them, right? Use a ruler, find the length of them. But if you're basically given a parallelogram and nothing else, not a non-specific quadrilateral, just a parallelogram, you always know that the diagonals are not congruent. Okay. The next part that we want to say is bisect each other. Meaning that the parts are congruent. I'm going to represent that by a different color to show you. But if they bisect each other, that means they split them up into different parts. 1, 2, 3. 1, 2, 3. If we use a different color for the other pair as well, parts of them are congruent. 1, 2, 3, 4. 1, 2, 3, 4. We'll get into talking about the angles that are given there. We have congruent triangles in those, but we're not going to talk about that right now. We'll be able to look at it later. Okay. This one has a lot of them. The more we add to them, the more that we see that parallelograms have, the more definitions. And this is why it's kind of helpful when looking at these for this one. We're going to look back at this one a lot coming up in the following weeks, looking at the properties of sides, angles, and diagonals for these. Okay. So you got to be able to apply them. So that's our definitions for those. Let's go ahead and continue. Our next one is a rhombus. Okay. Rhombus, rhombus, rhombus. So go ahead and copy that one down. Okay. By the definition of a rhombus, we do have parallel sides, but what makes it different than all other parallelograms is one thing that is consistent with a rhombus is that all 4 sides are congruent. So if you're ever given a rhombus and you know it happens to be a rhombus, the one thing you can always depend on is that it is all 4 sides are congruent. So we'll talk about that as well. So hard day today? Not at all. We're just looking at properties and how to apply them. Okay. You're going to want to hold on to this. If you have this, I think I'm going to let you guys use this on the test. If you have it. This conceals a lot of the properties that we're going to be doing on it. Okay. Just so that we can finish on time, and I think we have another one on this case. Let's talk about the angles. So because it's a parallelogram, the good thing that we know about this is opposite angles. So opposite angles are congruent. So we have a special property already because we have a parallelogram. In this case, I'm just going to add another side length to these to show the differences between these two. Okay, opposite sides or opposite angles are congruent. Adds to 360 degrees. adjacent angles are supplementary. I'm going to kind of abbreviate these, meaning that the angles that are right near each other add up to 180. Okay, and that's all we really want to get from that. That's not the real focus that we're going to make with this statement. Again, we've marked our triangles with the angles that are congruent. Okay, the opposites to each other will make it congruent to them. The next thing that we're going to look at here is sides. Let me kind of give myself a little bit more room. So sides for this case, the biggest key part that makes it a rhombus is for all sides are congruent. That holds in a rhombus. If it does not have that, it's not considered a rhombus. Okay. In this case that we're getting here, all sides are congruent, so I'm just going to mark them with just one line to show that all sides are the same. And that's all we really need for the side condition to work for a rhombus. Okay, that is basically the only thing we need for a rhombus to have. Okay, all sides are congruent. Okay, the only other thing I could say, because it is a parallelogram, what do we know about the sides? Opposite sides are congruent. Or sorry, opposite sides are parallel, not congruent. Or yes, they're both, I guess. Sorry. Late night last night. Sorry. Okay. Okay. Opposite sides are parallel. And then we're going to talk about just the last thing, diagonals for this case. And again, we're talking about the basic conditions that hold in a rhombus. Okay. One thing that we know is bisect each other. Bisect diagonals, I'll just put that. And the other thing that we can say about this as well is it makes a perpendicular bisector. Again, we're going to look at the angles again. For a perpendicular bisector for this, so if I'm going to do the diagonals through them, one through one angle, one through the other. The fancy thing that we know about this is the bisecting. Oh, what did I do? Oh, there it is. Sorry. The perpendicular bisector makes a right angle in the middle. Okay. Let's just have a fancy part about that we can use later. Again, we'll talk about in the future. And I'll put diagonals make a 90-degree angle. That's all I really want to say about rhombuses. Rhombi. A rhombus. What time do we get out of here? Cool. Plenty of time. Okay. Here we go. Yes.
I assume you copied the thing over there. All right, now.
Okay. The next property we're going to look at, the next type, is a rectangle. Is that the fourth one down below? Are we good?
Yeah.
Okay. With a rectangle, by definition, for a rectangle to be a rectangle, is that it's a parallelogram with all angles being 90 degrees. Okay. All interior angles fixed at 90. Not necessarily we could say congruence, right? Or I guess you can say congruence. All angles are congruent to form 90. So let's talk about this one as well. So we're again talk about angles, sides, and diagonals. Angles. So for this one here, we're going to talk about the angles. The angles just happen to be all are congruent. All are congruent. All are 90 degrees. Adjacent angles are supplementary. So they're all congruent, they're all 90, and if you add two angles that are next to each other, they're going to add up to 180, right? Their adjacent angles are supplementary. Okay, that is a key one that focus up on here. Okay, the more criteria we set forth to it, the more that it will get, deeper. We know it's a parallelogram because opposite sides are parallel, and if it's a parallelogram, everything else holds, right? The thing that separates a rectangle from a square is what? Sides, right? All sides are congruent. It's a parallelogram, so therefore opposite sides are congruent. So all the criteria holds in a square that doesn't hold in a rectangle. Okay. Let's talk about the sides. We're talking about sides of a rectangle is opposites. Opposite sides are congruent. And if we had to label that, I'm just going to label that with one mark, and then we'll do the top and bottom with 2. Opposite sides are congruent. Because it's a parallelogram, opposite sides are parallel. So the only definition we need, we're good after that. Opposite sides are congruent, opposite sides are parallel. And now that's all the criteria we need to have. Looking at the next part would be our diagonals. And I'm going to kind of write it. You guys can hopefully do it right below them as well. Diagonals. One thing that we know about the diagonals is diagonals are congruent. Are congruent. We'll go ahead and draw them in for my part. One part to the other, one part to the other. Diagonals are congruent. Diagonals are bisecting. Meaning it splits them into 2, and we're going to go and write that on ours as well. 1, 2, 3. 1, 2, 3. And the fact is we know that since they're congruent, we know that all these parts are also congruent. So all the 4 parts in a rectangle that are bisected are equal to each other. And that's what we're going to put as well. Bisecting parts are congruent. Good stuff? Easy so far? Awesome.
Also, I didn't get a chance to copy everything you wrote on Quadrilateral.
I'll be posting it today, so we have the time. We'll have the time. Okay, here we go. Flip it to the back side. We got more we got to talk about. Square. It's the next one, right? Okay. So because a square is the most unique one out of all quadrilaterals, it shares a lot of the properties that we need to look at. Will we be talking about squares? We can. It's not the one that we're going to focus on. For this to be a square, you need to have two specific properties, and it deals with both angles and sides. The first property is that it's a parallelogram. Okay, all equal sides and length, and all interior angles are 90. So it has to have 90-degree angles, and it has to have all sides equal. If it meets those two criteria, it's a square. Okay, and it follows that it has all the parallelograms, it has all rhombuses, it has all the criteria that are met by the previous definitions. So parallelogram with all equal sides and length, all interior angles at 90 degrees. All right, did you copy this down? So let's look at this. Let's look at angles. This is kind of the big final one. Angles all are congruent. All are 90 degrees. All are congruent. All are 90 degrees. Adjacent angles are supplementary. So it shares a bunch of these properties that we can look at. When we're talking about the sides, all sides are congruent. That's one of our big ones. And then all sides are also parallel. We're going to make our marking to show that all sides are congruent. All of our angles are already congruent by showing it's 90. To show all sides are congruent, we're just going to make a mark in like that. All four sides to show congruence. One mark shows that all sides are congruent. Yes. Last part of this one also is we know diagonals. We have a lot of special properties that come up with this. Bisect each other. So it splits it into two. We'll draw those in. Bisecting parts are congruent and form a 90 degrees, a 90-degree angle. So we're going to represent that in my green part. Because all parts are congruent, I'm going to go and mark them as 1, 2, 1, 2, 1, 2, 1, 2. Okay. And we also know that they form a 90-degree angle. Okay. Make a better right angle in there. So it shares a bunch of these properties that we're going to look at as well. Okay. Cool beans? We're good? Two more. How many more left we got? Two more? Cool. Let's do it. Some reason reset. Next one is a kite. Okay. Kite is the most unique one that we have. It is the most really weird looking thing. The reason why they call it a kite is because it looks like a kite, right? Something that should fly up in the air. The problem that we're getting here, for the definition for it to be a kite, it has two pairs of equal sides whose opposite sides are not congruent. Okay, the adjacent sides we're talking about would be congruent. We're not going to really focus up on this one that much. I do want you guys to be able to identify and tell me what properties it does hold and does not hold. So I just want you guys to be able to do that for this one. A kite is very unique quadrilateral. A kite is a very unique quadrilateral. It also forms from like a diamond shape, right? Diamond looking quadrilateral that we're looking at. But we'll kind of do these as well. Here we go. 10 minutes left. We can do it. This is angles. So angles, this is kind of unique and it's different than another kind of quadrilateral. It does not fit and coincide what we're looking at for a parallelogram. This is definitely not a parallelogram because opposite sides are not parallel, right? They can all intersect. So what we're going to say here is one pair. One pair is congruent. And we're getting that with our parallel sides right here. We're getting one pair that is parallel. The other side does not have to be. So I'm going to mark it with 2 and then the other one with 3. The other thing that we know that we haven't been putting in as well, because it's still a quadrilateral, all angles add up to 360. Add to 360. Not 180, 360. Okay? That's one thing that we know about that. Because it's not a parallelogram, we can't say that the sides that are near each other are supplementary. It just depends on how you want to add them and do them. So only one pair of them is congruent. Sides. To showing sides, we have opposite sides are not congruent. Are not congruent. But adjacent sides are congruent. And then the last part that we want to say is sides are not parallel. Okay? And I'll mark those in right now. No. Yes. Yes. Is Mr. Cruz in here? Sebastian? Oh, yeah. Sorry, I'm looking at you. Oh, can you go and see Mr. Hanson? Yeah. Bring your stuff. Bring your stuff. Sorry, I'm freaking out right now. Okay. Here we go. Opposite sides are congruent. So adjacent sides are. So then something like that. And then the final thing to talk about diagonals, and we'll finish these up really quick. Does not bisect. Does not bisect a pair. Perpendicular. Butcher that last one. Okay. Only one pair of them are bisecting, so this would be 1, 2, 3, 1, 2, 3, and they form a 90-degree angle. Finish up the last one, yeah? Okay, so this is one of the obscure ones that we're going to not really look at that much because it is a kite. The properties that stem from it are kind of weird and wacky. Only one pair of them that bisect each other. Opposites are not congruent, but their adjacent sides are. The angles add up to 360. They form a perpendicular. It's just a weird-looking type of quadrilateral. It is a different. It is a type, but we're really not going to focus on that one. Let's do the last one here. Last one is a trapezoid. If we're looking at non-parallel sides, would be a quadrilateral. If you have two pairs of sides, it would be a parallelogram. Then we have parallelograms within there. If we're talking about a specific type of quadrilateral with one pair of parallel sides, it would be a trapezoid. Trapezoids only have one pair of parallel sides for this. Okay? That is the main idea that we're getting from this part. Let's finish this up. Let's talk about the angles. The only thing that we know is adds up to 360. Doesn't need to be congruent with other angles. Can they be? Yeah. But the specific part that we're looking at is that they share a pair of parallel, one pair of parallel sides. So we'll just look at that the angles add up to 90 or add up to 360. The side portions of them, one pair is parallel. Only one pair is parallel. And we're going to denote that by an arrow going in the same direction on our lines to show parallels. That's really the only definition we want to really be able to see. Doesn't need to be congruent. Opposites don't need to be congruent. Okay. And then let's talk about the last part, diagonals. I'll write mine down below. The way that we want to be able to identify diagonals is not congruent. And not bisecting. Can they be? Yeah, but not always. So we're going to do that. We're going to show different sides to that. So this will be 1, 2, 3, and 4. To show that the sides are not congruent, we'll just leave those parts out. We'll just leave that out. Okay. And that would be it. That's our trapezoids. Cool beans? That is it. That is it today.